All right, so we've got integration by substitution, and this will be example 1F, we'll call it. And there's trig functions involved again. So you see the question up here. And I will also note that this is an indefinite integral. We don't have limits of integration. And that would be important here to note. So, don't we have a quantity within a trig function? Namely, 2 theta. So 2 theta is in the trig functions. And so that would be the logical thing to set equal to u, for u to take the place of. Take the place of, substitute. So, it looks like over here in the new one, we're going to have the secant of u, tangent of u, and those u's took the place of 2 theta. All right. As always, we always build the dx or the d theta, so, and everything gets built from the original substitution. Okay, dx, d theta. So you differentiate both sides with respect to theta. You know, theta takes the place of x. So 2 times theta would have a derivative of 2, just like 2x. With respect to theta, with respect to x, same idea. And then if you clear the fraction by multiplying by d theta, that's what that Greek letter is, we have du equals 2 d theta. Now, cool, d theta. But there's not a 2 in the original question. What is the coefficient in the original question? What is the multiplier up here? It's a 1, isn't it? Okay, maybe I should have more variety and put different multipliers out here. But if that's a 1, you go, well, the original question had a 1 in it, and the 2 fell in our lap. Oh, okay, no big deal. How about we cancel the 2 that fell in our lap and replace it with a 1, otherwise known as multiply both sides by 1/2. Multiply both sides by 1/2. So 1/2 du would equal 1 d theta. D theta, 1 d theta. So d theta is 1/2 du, and we'll put the 1/2 in front, and the du on the back, and it's all there. Everything's taken count of. Everything is accounted for, isn't it? All right, now, here's the deal. When we're integrating trig functions, I would suggest to you that you pull out that slide that had the derivatives of the different trig functions that was given to you before spring break. All right, that there slide that nice man gave to you. Wasn't that guy nice? What happened to him? He used to be so nice. Oh, I hope I'm still nice. I don't know. Maybe I never was. Oh well. Anyway, the 1/2 comes down, multiplier, numerical multiplier. The secant of u, tangent of u. He really is pretty nice. Because isn't the secant of a variable tangent of a variable? Isn't that the derivative of secant, right? So remember, when you're doing integrals, it's like, we give you the derivative, you tell us the original. Go back to your derivatives, and notice secant x, tangent x. Oh, so that would be the secant of u, and remember, plus constant. The derivative of secant of u is secant u tangent u. Boom. Yeah, it's going to fall out there. We were nice. You might say, what if this thing isn't one of those? It's more complicated. Calc 2. Ooh, isn't that exciting? All right? So look, in Calc 1, it's going to fall in your lap. It's going to be one of those derivatives sitting out there. Okay? And then, we need to remember that since the original integral involved the variable theta, that the answer should be theta. So 1/2 secant and u over there took the place of 2 theta plus c, kaboom. There it is. There's that one. All right? So, I don't know what else to say. Is everybody having as much fun as I? I miss you. I wish you were here. At least we can somehow enjoy this together. So, not only am I hoping it's making sense, but you're having a good time watching this, sitting there in your jammies and enjoying them. All right?